Descriptive Statistics and Inferential Statistics. So we had covered roughly how do you handle R, functions, and most of the things which are more related to the technical aspects of R. Now we come to the second leg, that is the statistical aspects of analytics, right? So as you know that statistics or analytics can be seen as a phased process where you start in the beginning. You might talk about descriptive statistics and then inferential statistics, then causal statistics, and then it could be further about predictive analytics, and furthermore it could be prescriptive analytics also. So in this session what you will be talking more about would be about statistical variables, descriptive and inferential statistics, correlations, frequency taps, crosstabs, t-test, ANOVA, and NV ANOVA. NV ANOVA is more specifically talking about people who are into market research, so we'll be stressing more on ANOVA rather than more than two-way ANOVA, right? So let's start off with the session. Introduction to statistical variable. So we'll understand from the perspective of statistics what a variable means. A variable has a different meaning when you look at this from the perspective of a database. So what we would call as a column is called as a variable in statistics or analytics. The same would be called as a dimension when you look from the perspective of reporting. The same would be referred to as a feature when you're talking about machine learning. Basically they are the same. So let's understand this in depth. Types of variables. So when you're talking from statistical or analytical perspective, you can basically bifurcate data into qualitative, quantitative, dependent and independent variables, right? Now again you need to understand that dependent and independent is basis the use of the variable, so we'll keep that aside right now. So it doesn't make sense to look at data from this current on-screen depiction, because if you look at data it would basically be bifurcated into something like structured versus unstructured data. Unstructured data is a different breed, we won't be talking about that as part of this course. And within structured data you would have something like a numerical data and a categorical data. So what is referred to over here as qualitative is nothing but a categorical variable, and what is shown on screen as quantitative is nothing but your numerical variables, right? And again if you look within the categorical you have three forms. So what you see right now is nominal and ordinal, but there is one more which is called as binary. So within qualitative categorical variables, so I would refer that as categorical variables, you would have something which is called as binary, which takes only two forms, 0 and 1, true, false, yes, no, male, female, all those kind of variables. And then the second would be nominal, wherein it is more than two levels in the data. So something like marital status, which could be married, unmarried, don't know, something like that, or married, unmarried, separated, divorced, something like that, right? So basically let's talk about variables which has more than two levels in the data, but it doesn't have a sequence of importance. On the other hand, if you look at something which is called as ordinal, it is nothing but a form of nominal variable but which has sequence in it. So something like color of light signal, right? So if you just see on the previous slide as we are seeing right now, wherein we are seeing that chart, so gender doesn't have an order of sequence in importance. So for example male, female, right, doesn't have importance in terms of sequence, so both are equal, right? So color of traffic light, red, orange, green, all of them are equally important. You cannot say green is more important than red, right? On the other hand, ordinal would be about that categorical data which has a sequence. For example, your percentages, or you can say the class you scored in an exam. So whether it's pass class, second class, first class, distinction, this has a sequence of importance, right? Now again, data can be transformed. So something which is nominal for one person might be ordinal for the other. Say for example, color might not be ordinal when you look from the perspective of traffic lights, right? But for somebody who is into particle research, or somebody who is more into say the paint industry, for them it might be important because the color red has higher concentration of pigments as compared to the color white. So yes, it has a sequence over there. So when you are splitting the white light through a prism, basis the different wavelength, the light gets separated into different spectrum, and yes, it has a different wavelength. So if I convert that color of light into a wavelength spectrum, it has different sequence, and one is high and one is low, right? So yes, variables can be transformed between these forms. Now, when we can come to quantitative, right, that is numerical variables, we basically have two scales. One is the ratio scale and one is the interval scale. The basic differentiation is that an interval scale doesn't have an absolute zero. That means if you refer to something like temperature in degrees Celsius or Fahrenheit, you cannot say that a zero means absolute zero. That means 0 degrees Celsius doesn't mean that there is no temperature. In fact, it is very cold over there, right? So it doesn't have an absolute zero. It's a reference scale. On the other hand, a ratio is just something wherein you are doing a ratio of two things, right? Now, when we're talking about quantitative variables, it makes more sense to talk about two things. That is about discrete variables and continuous variable. So anything which can be counted would be discrete, and anything which is measured is called as continuous, right? So if somebody is asking you what is your age, you typically say that it's 24, 34, 36, whatever is your age, by referring to your age as on the last birthday. So you're basically counting the number of years lapsed from your birth to your last birthday. That's what you're doing. You're counting it. So when you're counting it, it is discrete. It cannot take an integer value or something in between. But when you refer to your age as on today, it would be about how do you refer to age as on today. So you're basically measuring number of days lapsed, number of seconds, all those things. So it basically turns out like 36.54, right? So that's how you see, right? So data can be continuous as well as discrete. It's the way you treat them, right? So now we'll go further and actually see what these are, right? So you can see on the screen discrete variables. So example for reference is shown that a discrete variable does not admit intermediate values between two specific numbers. So that goes by the very same clause that if you count something, you cannot have something in between. So you cannot say that if I'm counting the number of students present in a class, it can be 1.5. No, it's not possible, right? Because those would be 1, 2, 3, 4, something like that. Continuous variable, on the other hand, because it is arising out of something which is measured, can take values in between also. Categorical variables or qualitative variables, as we were talking about, needs to have nominal, dichotomous, which is binary, and ordinal. We have spoken about this. So the screen talks about that only. It takes into consideration a few examples of gender, which is between male and female, right? And then hair color, which has blonde, brown, brunette, red, and all those things. And it basically talks about a class in the data. Yes, again, brown hair is not important as compared to black. So that is why we refer to this as a nominal. Now, if it becomes something of importance, then yes, we will have to refer that as ordinal. Dichotomous variable are variables which takes only two levels: yes, no, true, false, 0, 1. That's why it's called binary. Right? So these are the variables which are very important when we talk about decision making and analytics. So for example, if a person says that he owns a phone or he doesn't own a phone, so mostly when you say yes or a no, which can be codified as a 1 for a yes and a 0 for a no. Now, when we talk of ordinal variables, yes, it's something similar to a nominal variable, which we have already covered, but it has a sequence to it, a higher to lower or a lower to higher sequence, and that is why we call it as ordinal. It has an order in it, right? And obviously, it has to be more than 2. So if it has only 2 levels, it won't be ordinal, it will be termed as binary. So that's how we define an ordinal. Interval variables. So these are variables which are similar to ordinal variables, except that it doesn't have an absolute zero, right? So basically it would be somewhere in between. For example, suppose you have a variable such as monthly income that is measured in rupee value, and 3 people have a value of around 10,000, 15,000, 20,000. The second person makes 5,000 more than the first person, and the and 5,000 less than the third person, and the size of these intervals is same. So if these two other people who make INR 90,000 and 95,000, the size of that interval between these two people is also same, but the difference is in perspective. So if 10,000 and 15,000, you can say that the second person is getting 5,000 more than the first person, but there is another set of people or audience wherein the gap is also 5,000, but that value is 90,000 and 95,000, right? So it's about the interval. So from the interval perspective, it is same, but it does not have an absolute comparison. So the disposable income for this 90,000 and 95,000 guy is different, and the disposable income for a 10,000 and a 15,000 guy is very different. right? And that is what actually happens. It makes more sense to look at interval variables from the perspective of temperature, wherein you're saying that a 98.3 is taken as a threshold value to consider that a person has fever or not fever, right? So if your temperature is above 98.3 Fahrenheit, right, you typically say that you have temperature, right? But if you actually talk to a person who is having febrile convulsion, so basically a condition wherein a kid below the age of 5 years has been exposed to convulsion that is called as normal terms as fits, which comes out of the brain not being able to handle the sudden rise in the temperature. Now if this kind of a patient is referred to in a hospital, even if the temperature rises to 99, the nurse would say that there is no temperature, this is very normal, unless and until I see a 100 on the scale, this person will say that it's within control, right? Because in febrile convulsion, what is important is sudden rise in temperature and not normal rise in temperature. So till the point it rises to 100, it's okay for the diagnostic person. So again, it has different meaning for different people. So that is about interval variable, right? Now, ratio variable has all the properties of interval variable and has a clear definition of a zero, which was lacking in the interval variable. So, a ratio variable will have a typical zero definition, which means, so if you look at temperature again as a variable, a Kelvin scale, right? So, if you are measuring energy in Kelvin scale, a zero means an absolute zero. That means when you're measuring on a Kelvin scale, if a process has zero Kelvin temperature, that means there is no energy present, right? That's absolute zero. So now why are these important? Why do we need to understand what is nominal, ordinal, interval and ratio? Is because based on the type of variable you can do certain compute activity in terms of statistical analysis. So if a variable is nominal variable, you can do a frequency distribution. If it is ordinal, you can do frequency as well as median and percentile computation. If it has an interval scale, then you can do frequency, median and percentile computation, addition and subtraction, mean, standard deviation, everything is possible. And if it is a ratio, you can do almost everything. Apart from that, you can add coefficient of variation also. So typically based on these variables, you will analyze and decide which should be the variable which is part of your analysis, and that is why it is very important. Now we'll come to the second aspect, that is talking about dependent variable and independent variable. Now the definition of a dependent variable is something which is affected by an independent variable. We'll talk more about independent variable later on. So for example, salary is typically seen as a dependent variable, that because it's very random, right? And it depends upon a host of other things like your age, your experience, your qualification, the grade from which you have qualified, the tiering of the college or the educational institute from where you have taken your qualification or your degree, right? And that is why it is dynamic, it is random, it is dependent on all these things. Whereas your college degree is not random, so once you have taken it, it won't change. So if you have done MSc statistics, it won't become MSc in some other subject, MSc mathematics for example, right? So it is comparatively non-random, but it has an effect on your dependent variable, that is salary. So independent variable is something which is explaining your dependent variable. So salary is being explained by your experience. So let's take only two variables, say salary and experience. So typically experience, once you have got 4 years of experience, it cannot become a 3-year experience, right? But your salary, once it has become 4 lakh, it can strip down to 3 lakh also. That means it is random. It depends upon a host of things like market condition, your present experience, job, whether you have a job on hand and you're looking for a job, or you don't have a job and you're looking for a job, that decides your next offer, right? So explanatory variables are also one synonym which is used for independent variable, which decides or influences your dependent variable, which is a response variable, right? So we'll talk more about this as we go forward in your journey about analytics. Now we'll have a brief introduction into descriptive statistics. So let's start into that deep dive. So when you're talking about descriptive statistics, you basically have some key things which you have to talk about, which includes central tendency, so measures of central tendency, and measures of dispersion. We'll talk more about measures of central tendency as of now. So what is central tendency? Basically, the word itself defines that there is a tendency of data to move towards a central portion, right? And that's what we're talking about. So when you look at data, if it is coming out of a natural process, say for example, if you talk about age, right, which comes from natural, you don't cook up this data, right? So age of a person is coming out of a natural process of aging, and if you take huge volumes of data, typically it will follow a tendency that bulk of the people will try to come to the mean value of the average value, right? So we have been talking about average values quite often without actually understanding what it means. So average talks about where the bulk of the data is concentrated, right? So if you talk about salary of people in an organization, and if you try to take a mean value or the average value, it basically talks about, on an average, what is the value of salary which most of us get in that company. That is what we are talking about. Median, on the other hand, is like partitioning the data into two equal halves and just getting the central portion. And mode basically means what is the highest frequency of salary which you can observe in the data, right? And then it's measures of spread, which is also called of measures of dispersion, wherein you have range, quartiles, percentiles, deviations, variance, and standard deviation. Then you have measures of symmetry and measures of pickedness. So we'll talk more about this as we go forward. So now we come to inferential statistics. So a brief introduction into inferential statistics. So inferential statistics are techniques that help us to make generalization about population by drawing some small sets of data from the whole population. Now, first of all, you need to understand why is this important. This is important because now, since today we are in a heavy compute, heavy storage phase wherein data is not a problem, but the basic example or metaphor which I would give to explain this is that why do we take samples? So you go to a doctor and the doctor says that he is doubtful that you have, say, something like you may have contracted something like malaria or cholera. He's not sure and he recommends you to take a test at a diagnostic center. You go to a diagnostic center and imagine he takes out your whole blood out of your body. Now, is that advisable? No, because it will destroy you, right? So what you expect is that if he takes a small sample of your blood, does that test, and based on that you can reasonably do some inference about the whole body, right? And that is why you do sampling. Now inferential statistics talks about whether my estimates are really close to the population and whether I can make generalization about the whole population. That's inferential statistics, right? So it's about estimation of parameters and testing the statistical hypothesis underlying them.